Good afternoon to everyone. So now today topic is economic, right? Economic geology. Okay, economic geology. So now what is economic geology? You see here. So economic geology is a branch of which one? Branch of geology. So that deals with that deals with the economically valuable geological or earth minerals which are utilized by mankind to fulfill his needs, right? So what are those materials? Materials means precious base metals, non-metals, and construction grade stones, and also petroleum minerals, coal, etc., etc. So these are the some of the materials, right? So this subject provides which one detailed knowledge of all these minerals, like it's one like their origin, process of formation, and mutual relations and time sequence, and also control of localization and metallogenic epoch and province, and also classification, and besides their mineralogy and uses and mode of occurrence and geological and geographical distribution, and also last one is reserves production and all other related facts in this. These are the came in this economic geology, right? So now you see here. So now economic geology nowadays in nations which are having large amounts of minerals, right? So those are considered to be economically superior. So the more important substances of economic value it derived from the rocks underneath the surface or iron for steel, water for drinking purpose, and also fuels like coal and oil and building stones, lime and cement, and also clays. So these are for bricks making and pottery and road metals, and also ornamental stones and marbles, soils, and last but not the least, the precious, right? The precious and useful metals, precious and useful metals. These one. Like gold, right? Gold and also silvers. So these are the very precious and useful metals. So in the search for these substances and knowledge of their distribution, character, and occurrence, and also uses. So slowly and steadily it got accumulated, leading to the theories regarding the which one? Origin. So the nation's economy depends upon the which one? Mineral industry. Mineral industry growth and chief depending upon the knowledge derived from economic geology. So this is the very important. So, the knowledge of economic geology, it makes man perfect so that he will be able to guide people for continued supply of material needed for mineral industries, etc. Right? And consumption of economic mineral resources needs a discovery of new areas having economic minerals so that the industries continue to get regular supply of the materials needed for mineral industries to grow. Right? So now what are the economic minerals? So minerals which are of economic value, those are called economic minerals, right? So now, what is mineral? A mineral is a naturally occurring homogeneous inorganic compound which has definite chemical composition and a fixed internal atomic arrangement. So that is called mineral. And what is mineral deposit? A mineral deposit, or to be more particular, an economic mineral deposit may be metalliferous or non-metalliferous, right? So now the gold, copper, those are the very precocious minerals, right? So the gold, copper, and iron or nickel, etc., those are being to metallic group, whereas gold, clay, petroleum, gemstones, etc., fall under non-metallic groups, right? So minerals are divided into which one? All right, wait. So those are metallic minerals and non-metallic minerals. These are classified into two groups, metallic minerals and non-metallic minerals. So metallic minerals are ferrous group. They include minerals like iron, chromite, manganese, and also nickel. So in these metallic minerals, non-ferrous group, those are non-ferrous group in the copper, lead, zinc, tungsten, aluminium, and vanadium, and also others. These are the non-ferrous group, right? And non-metallic minerals. Non-metallic minerals are, they are mica, steatite, and asbestos, and also others. So the economic minerals are thus broadly classified into two types. First one is which one? Metal, right? First one is metals. And second one is non-metals, right? Non-metals. So metals are gold, copper, iron, nickel, right? And also those metallic group were coal, clay, petroleum, gemstones, etc. Right? So these are fall under non-metallic groups, right? And everyone knows, that is talk about politics. Everybody wants money, right? So there are very few who really knows very much about this money and politics, right? At least it is clear that all money is based on something which the earth has provided out from its vast storehouse of treasures in the form of economic mineral material, right? So the metals are likely to occur in a complex geological settings. Thus, their discovery commonly require detailed geological exploration. So these economic geology is closely related to various disciplines, particularly to various branches of geology like mineralogy, structural geology, petrology, geomorphology, and also remote sensing, etc. So the mineral deposits, whether they are metalliferous or non-metalliferous, those are nothing but accumulations or concentrations of one or more useful substances which are scattered in the outer crust. So the elements that enter into the materials of mineral deposits, it have been derived either from rocks of outer crust or from magmas. So that have cooled to form which one? Which rocks is formed? Igneous rocks, right? The minerals which constitute the Earth's crust are very few in number. So about how much? 2000 minerals, right? 2000 minerals species are known, right? They are recognized 2000 minerals. So out of which 50 are rock forming minerals and 200 are regarded as economic minerals. How much? 200, right? 200. These are the economic minerals. So 50 are which one? Rock forming minerals. Rock forming minerals. Okay. So the extreme concentration of formally diffused metal in rock are called metalliferous deposits. Which one? Metalliferous. Okay. Metalliferous deposits. It close observation reveals that the desired metal is not seen independently, but it is chemically bound with other elements. And also it is known as which one? Ore mineral. So ore minerals are found associated with other minerals or rock matter called which one? Gangue. Right? So now what is the ore or ore mineral here? So the combination of ore minerals and Ganju minerals is called ore. Okay? Ore. O-R-E. Ore. So ore is found enclosed in the rocks. Now you see here, what is mineral? Mineral form which one or more metal mineral can be extracted profitably. It is known as ore mineral. So it can be high grade or low grade depending upon the percentage of the metal present in this, right? So now the an ore you see here, the discipline of economic geology covers all aspects pertaining to the description and understanding of which one? Mineral resources, right? So the purpose of this process-oriented course is to provide a better understanding of the nature and origin of mineral occurrences and also how they fit into the earth system. You see, this is the gold and this is the lead, zinc and diamond, right? So now ore minerals. So ore mineral, it can be defined as substance, right? Now you see, so what are ore minerals? So most metals are too reactive to exist on their own. in the ground, right? So instead, they exist, right? Exist combined with other elements as compounds called which one? Ores, right? Ores. So ores are raw materials for making which one? Metals. Okay. So now minerals are those in which individual crystals are composed of unit cells or basic unit layers or of two or more types, right? So minerals are inorganic catalysts that function as regulators of metabolic activities in the our body, right? So isolation of elements in some of the in previous or studied in maybe up to 10th, right? So you can already knows about that, right? Those very few metals such as the which one gold, silver, platinum. So these are the very costly metals, right? So the process of extraction metals ore buried deep underground is called what is that? Mining, right? Mining, mining. What is the mining? The process of extraction or extracting metal ores that buried deep underground. So that is called mining. The metal ores are found in the earth crust in varying abundance. So the extraction of metals from ores is what allows us to use the minerals in the ground. So the ores are very different from the finished metals. So that we see in building and bridges, right? So they consist of the desired metal compound and the impurities and earthly substances. So that is called Ganju minerals. So the useless minerals which occur in association with the ore, right? So that is called Ganju metal. It's a Ganju mineral, right? So the extraction of metals and the isolation occurs over a few steps. Those are concentration of ore and isolation of metal from concentration ore and purification of the metal. So now what is the difference between ore and minerals? You see here. So mineral is the, what is that mineral? All the naturally occurring substances that are present in the earth crust are known as minerals, right? And ore is what? Ores are usually used to extract metals that is economically. So a large number of ores are present. And now in minerals are not ores. But all ores are minerals. Remember, all minerals are not ores, but all ores are minerals. So minerals are native forms in which metals exist. But ores are mineral deposits. Right? So now, what are ores and what are minerals? Already you listen here. So now, how are ores extracted? How? The process of the process of that The process of removing metal, right? Metal from the which one? Ore. So that is known as metallurgy. 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 So the ore is generally associated with the earthy impurities like sand, rocks, and limestone. It known as gangue or matrix. So a substance added to ore to remove the impurities is called flux. Flux. So the combination of gangue with flux in ores, it forms a fusible material called slag. Okay, slag. So now the concentration of ore is the process of eliminating gangue from the ore. It depending on the nature of the procedure. So those are carried out gravity separation and magnetic separation. Gravity, right? Gravity separation and magnetic separation and fourth foliation, sorry, flotation process and leaching method, right? So now what is the gravity separation? So this method is based on the difference in the gravities of ore and gangue particles. And magnetic separation means a powder, right? Powder of ore is carried through a conveyor belt that runs over two rollers, one of which is magnetic in this operation. So the magnetic particles are attracted to the magnetic roller and fall down first. So that is followed by the non-magnetic particles. And froth flotation process. So this method is based on the difference in the wetting properties of the ore and the gangue particles. So the froth flotation method is used exclusively for sulfide ores. Which one? Sulfide. 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 Sulfide ores. And next one is the last one, leaching method. So in this method, the powder bauxite ore powder is treated with mud and a concentrated solution of sodium hydroxide, right? Sodium hydroxide. So the ore dissolved in the sodium hydroxide to form which one? Sodium aluminate and silica dissolved to form sodium silicate, right? Sodium silicate. So the other impurities remain undissolved and those are later filtered out. So this process is used when the ore particles are soluble in such a solvent in which the gangue particles, it cannot be dissolved, right? So we have some of the other methods of this extracting ore material. Those are first one is crushing and grinding. Crushing, okay? Crushing and grinding. GRINDANG. So crushing and grinding means crush. Crushing and grinding, those are usually carried out in a sequence of operations by which the lump size is reduced step by step. So the purpose of this method is to reduce the size particles and to release impurities. So these are the three types, right? Three types. First one is primary crushing and second one is secondary crushing and third one is tertiary crushing. So grinding or further has two stages. This first one, right? So those are coarse grinding and fine grinding. So all the metals have some physical and chemical properties The most reactive metals are which one? Now, potassium, right? Potassium, K, and sodium, and calcium, and magnesium, and also aluminum, and iron, and mercury, and copper, and also silver, etc. So these are the all the elements have some physical and chemical properties, right? So now the extraction of ore from highly reactive metals are calcination, roasting, and smelting. So now what is the calcination? Calcination. 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 So calcination is a process that involves heating ore in the absence of air in order to remove water from hydrate oxide at temperatures below the melting point. And roasting. And roasting means roasting is a process in which ore is roasted, right? Roasted to temperatures below its melting points, usually in the presence of air. And also next one is smelting. Smelting means it is the process of reducing oxide ore with carbon at a high temperatures, right? And now, so ore deposits. Ore deposit means the mixture of, so the mixture of ore mineral and ganju mineral is known as ore deposit. The ore deposit is generally found enclosed within the container. The deposit has to be of considerable size and volume, and often in terms of millions of tons, to quality as an ore deposit. Hence, the definition of an ore deposit is also size dependent. Okay. Now, you see here, the classification of scheme for ore deposit, it is very simple classification of ore is achieved on the basis of igneous okay, igneous, sedimentary, and hydrothermal categories. So this subdivision is very similar to one used by Elon D 2000, who stated that all mineral deposits can be classified into three types based on process, namely magmatic deposits and hydrothermal deposits, and also superficial deposits formed by surface and groundwaters. The ore forming processes can overlap between which one? Igneous rocks and hypothermal, and between sedimentary and hydrothermal. Okay. So the ore deposits. Ore deposit formed when a useful commodity is sufficiently concentrated in an accessible part of the earth's crust so that it can be profitably extracted. The ore deposits are naturally concentrations of useful metals, minerals, or rocks which can be economically exploited. So the concentrations that are too small, low grade for mining, those are called occurrences or mineralizations, right? So the mineral deposits are basically valuable rocks. So their formation is compared with processes that have produced ordinary rocks, and it is investigated with petrological methods, and mineral deposits can also be thought of as a geochemical enrichment of elements are compounds in the earth crust, which is determined by their chemical properties. So the exploration result can be translated, right? Translated into a mineral resource, right? Mineral resources. Once it is clear that an occurrence of intrinsic economic interest exists in such form and quantity that there are reasonable prospects for its eventual exploitation, right? So now you see some of the important definitions here. So what is ore? Ore is a type of rock that contains minerals with important elements, including metals that can be extracted from the rock at a profit. So that is called ore. And ore deposit means ore accumulation. Ore accumulation. So that is part of the crust where ores are concentrated. That is called ore deposits. And Ganju. Ganju means commercially worthless material, right? Worthless waste material. It means waste materials that surrounds or it is closely mixed with a wanted mineral in an ore deposit, right? And you see, the naturally occurring substances occurring in the earth crust along with impurities are called minerals. So minerals are extracted through ores and the impurities associated with the ores, those are called ganju. This one. Okay. So the mining means extraction of ores or other valuable minerals from the ore deposits. So that is called mining. So this is open cast mining, right? So now you see here, a metal is a solid material, right? So that is typically hard, opaque, shiny, and features good electrical and thermal conductivity. So metals are generally malleable, fusible, and ductile. So it is currently in 91 out of the 118 total elements on the periodic table. So those are classified as metals, right? So a metal is a chemical element that is good conductor of both electricity and heat and forms ionic bonds with non-metals. So in chemistry, a metal is an element, right? So and compound are alloyed characterized by high electrical conductivity. It means easy, right? So in a metal, atoms readily lose electrons to form positive ions. So those ions are surrounded by delocalized electrons, which are responsible for the EC, electric conductivity. You see here some of the metals. So these are the aluminum and this is the cast iron and this is copper and steel and metal sludge and this is bronze. Okay. Bronze means copper plus tin, right? Copper plus tin. Copper percentage is 80%. Remaining tin is 10, 20, right? So that is called bronze. So this is the brass. Okay. So now you see here this the silver, iridium. Iridium is the very, very important and also is the very, very expensive and rhenium. So metals are solids, right? So metals are hard. Those are lithium, potassium, sodium. So metals have metallic luster. Luster means shining. Okay. And metals are malleable. Malleable means it can be beaten into thin sheets, right? Thin sheets. Metals are ductile. It means it can be drawn into wires. And metals have high melting points. High melting points means gallium and cesium. So those have low melting points. They melt in the form of the hand also, right? So metals have high boiling points and metals are good conductors of heat and metals are good conductors of electricity also and metals are sonorous. It means produce sound when beaten, right? Now you see metals are broadly classified as ferrous and non-ferrous metals. So ferrous metals means those are include steel and pig iron. Pig iron means with a carbon content of a few percent, right? And alloys of iron with other metals such as stainless steel, right? Stainless steel. So these are the ferrous metals. And non-ferrous metal, those are any metal including alloys. So that does not contain iron in appreciable amounts. So they are generally more expensive than ferrous metals. And non-ferrous metals are used because of desirable properties such as low weight and higher conductivity and non-magnetic property resistance to corrosion. Okay. And among metals, there are several subgroups is there, including transition metals and noble metals and also alkaline earth metals. Now you see here some of the non-ferrous metals. So this is the copper, brass and aluminium, tungsten, lead. We already seen this, right? Now common ore and gangue minerals. So it is estimated that there are about 3,800 known minerals are there. So that have been identified and classified. So only a small proportion of these make up the bulk of the rocks of the earth crust. And it has the common rock forming minerals. Likewise, a relatively small number of minerals make up most of the economically viable ore deposits of the world. So the following compilation is a breakdown of more common ore minerals in terms of chemical classes. So that is based essentially on the anionic part of the mineral formula. The compilation also includes some of the more, it's common ganju. It's called ganju, right? So which are those minerals that form part of the ore body, but do not contribute to the economically extractable part of the deposit. So now you see here the compilation including ideal chemical formula is subdivided into six sections or six categories. First one is native elements and second one is halides. Third one is sulfides and sulfosalts and fourth one is oxides and hydroxides. Fifth one is oxysalt and sixth one is silicates. Okay. So now we see one by one native elements. So now what are the native elements? Those are both metals and non-metals. Metals and non-metals exist in nature in the native form, where essentially only one element exists in the structure. So that is copper, silver, and platinum. So these three are all characterized by this cubic close packing of atoms, and it have high densities also and are malleable and soft. So the carbon atoms in diamond are linked in tetrahedral groups. It forming well cleavage. So and very hard and translucent crystals. So now the sulfur, right? Sulfur occur as rings of 8 atoms and forms bipyramids or its amorphous, right? You see here, these are the metals. Metals means gold, silver, platinum, palladium, and copper. These are the important metals. And non-metals are sulfur, diamond, graphite. These are the non-metals. Okay. Now second one is halides. So the halide mineral group comprises compounds made up by ionic bonding. Hello? Such a So now minerals such as halite and sylvite. So those are cubic and it has simple chemical formula and those are highly soluble in water. So halite sometimes form as ore minerals such as chloroargyrite and atacamite, right? Atacamite. So halite are NaCl and KCl, AgCl, CaF2 and Ce2Cl. These are the halides. Halide, sylvite, chlorari, chlorargyrite and fluoride and atacamate. So these are the halides. Now third one is sulfides and sulfosalts. So this is the large and complex group of minerals in which bonding is both ionic and covalent in character. So this sulfide group has the general formula A5 and AM and XP, right? So where X means the larger atom. It is typically S, but it can be AS, SB, TE, BA, or AC. So and A is one or more metals. The sulfosalts, which are much rarer than sulfides, and it have the general formula AM, BN, XP. So where A is also commonly Ag. Ag means which one? Silver, right? So Ag, copper or lead and boron is commonly as As, Sb or Bi and X is S. So the sulfide and sulfur salts minerals are generally opaque and heavy and have metallic or submetallic luster. Okay. Now you see some of the names here. And sulfur salts are tetrahydrite and tennantite and enargite. So these are some of these sulfur salts. And last one is oxides and not last, fourth one, oxides and hydroxides. So this group of minerals is variable its properties, but it is characterized by one or more metal in combination with which one? Oxygen. Oxygen are hydroxyl group. So the oxides and hydroxides typically exhibit ionic bonding. The oxide minerals can be hard, dense, and refractory in nature, but it can also be softer and less density and forming as products of hydrothermal alteration and also weathering and anatase like this pyrrolite, right? Hematite pyrrolite. So hydroxides such as goethite and gibbsite. So these are typically the products of extreme weathering and alteration. Now fifth one is oxysalts, right? So the carbonate group of minerals form when anionic carbonate groups. Those are linked by intermediate cations such as calcium, magnesium, and iron, right? So these are some of the carbonates examples. Also, and silicates. This is also very important, right? So silicate groups is the bulk of the Earth's crust and mantle is made up of silicate minerals. So that can be subdivided into several mineral series based on the which one structure and coordinate of the tetrahedral anionic group. So the silicate minerals are generally hard and refractory and translucent, translucent, right? And most of them, it cannot be regarded as ore minerals. In that, they do not represent the extractable part of an ore body, and the list provided below shows only some of the silicates more commonly associated with mineral occurrences as Ganju or alteration products. So some silicate minerals such as zircon and spodumene. So these are ore minerals and represent important sources of metals such as zirconium and lithium, respectively, right? So and also others such as kaolinite. Those are mined for their intrinsic properties. Okay, right. So now in magmatic process, magmatic process, magmatic process. So in magmatic processes, so this is also very important thing. So all igneous rocks are products of magma um, consolidation, right? So those rocks are made up of two groups, like minerals, like essentially minerals and accessory minerals, essential, essential minerals and accessory minerals, ACCESSORY, accessory mineral. So minerals in rocks whose presence and absence, right? Whose presence and absence change the identity of rocks are called essential minerals, right? So what is the essential minerals? Minerals in rock whose presence and whose absence change the identity of rocks. And whereas minerals whose presence and absence have no effect, right? No effect on the identity of the rocks. So those are called accessory minerals, right? Those are called accessory minerals. So for example, an igneous rocks like granite, you can take granite. So granite which comprises of minerals such as quartz, quartz, feldspar, and also biotite, and also muscovite, and chlorite, iron. These are some of the examples. So among these minerals, quartz and feldspars are quartz and these feldspars are essential minerals. And remaining all other minerals like biotite, muscovite, chlorite, iron. So these are the accessory minerals. So iron will be of very small proportion and most uncommon constituents in granites. So such uncommon or accessory minerals, it formed from magma may get concentrated into bodies of sufficiently, that is big size to form economic mineral deposits. So such valuable concentration of mineral deposits of magmatic origin, those are called magmatic, right? Magmatic concentration deposits. Those are, they are direct um, derivatives of magma. So that process is called magmatic concentration process, right? Magmatic concentration process. So this magmatic concentration deposits are, those magmatic concentration deposits are formed during differentiation of metal bearing magma directly from melts of ultra basic, basic or alkaline content. So now magma, which is hard molten rocky material, slowly it starts cooling, right? Starts cooling with fall in temperature, less temperature, right? So not only it cools, but also splits into different layers of different composition before getting consolidated. So most of the magmas are probably not homogeneous in composition. Parts may be rich in ferromagnesian constituents. So in silica, in sodium also, potassium also, those compounds in volatiles or in other substances, right? So when the composition of magma cools, it crystallizes. What happens there? It crystallizes and separates into fractions by the process of differentiation, right? Differentiation. And there are termed as magmatic ore deposit, right? So the most insoluble substances in many magma crystallize first. During differentiation, the more mafic parts of the magma, it may enriched in chromium, and also nickel, right? And platinum, titanium, and also iron, right? And also iron. So now such products derived from magmatic fraction after the process of differentiation. So in generally, uncommon and accessory mineral constituents like zircon, apatite, and also titanate and ilmenite and magnetite, chromium. So those are the minerals forming earlier than the rock forming silicates like olivine, augite, hornblende, and also orthoclase, mica, and quartz. So their crystallization from magma, it will be in a sequence having quartz, that is the last mineral to crystallize. So this order of crystallization of minerals in a sequence from magma, that is known as Bowen's discontinuous reaction series. Bowen's, Bowen's, Bowen's reaction series, right? So all economic minerals originated from which one? Magma during its course of crystallization prior to the rock forming silicates. Those are called early magmatic mineral deposits. Which one? Early magmatic mineral deposits. So all economic minerals, it formed in the final stage of magmatic crystallizations. So those are referred as late magmatic mineral deposits, right? So today topic is over. Okay, now I will stop here.